talk about food chains, food webs, food patterns. Please write your essential question at the top of the journal page where you're going to do your foldable. So this is just a quick refresher for the activity we just did, and especially for the kids in ISS. You got images of these different organisms, and you should have put them in order from left to right according to who eats what. So that if the fish gets eaten by the pelican, then the fish should be on the left and the pelican should be on the right. Or should be on the right. Okay, and so what you ended up making was a food chain. So on the front half of your foldable where it has that kind of food chain, food web pictured, and it has food chain in a line, this is the definition you should be writing down. And we're going to talk more about what these arrows mean in just a minute. Just make sure you get this definition down. Okay, and so you should already have this filled out on your foldable, and if you don't, make sure you get a chance to do it. Okay, and so trophic level on the inside of your foldable, we're starting there. It's the first definition. And as you'll notice, we start our trophic levels, like the first part of your trophic level is going to be the producer. A lot of people like to put the sun there, and while the sun is the source of energy for producers, the sun itself is not an organism. Like, producers are not eating the sun. So while we know in our heads that the energy comes from the sun, we start our food chains or webs or pyramids with producers. So please keep that in mind. Your detritivores are your decomposers. And we'll talk more about them in a minute. And then we just go primary, secondary, tertiary, first, second, third. So there are quaternary and higher levels of higher trophic levels. We usually just concern ourselves with the first three, though. Like I was saying on the last slide, a producer is an organism that makes its own food. So on the front of your foldable where you have producer, you should draw a little sun beside it. Okay? Hint, your producers are usually photosynthetic. At the end of this, I'm going to be checking for these symbols and things on the front of your food chain as well as you having your notes filled out. And also on your notes, on the inside where you filled out your definition of producer, off to the left, draw the sun symbol there as well so you have a key for what the front of your foldable means. Okay, and so if you're not a producer, you're a consumer. Consumers are kind of cool because they get to eat. Num, 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 num. They're delicious, delicious food, or delicious for them. So you should put a check mark next to all your consumers, and there should be 4 of them. And then on the inside of your foldable where you put the definition of consumer off to the left, draw a check mark. You're making your key here. All right, so your primary consumer or your first consumer, yay, first, like primary school is the first kind of school you go to. Anyway, label your primary consumer on the front of your foldable with a number 1, and also label primary on the inside with a number 1. Hint, your primary consumer is going to eat the producer. So if you did not put a number 1 by zooplankton, you should put a number 1 by zooplankton. And after primary comes secondary. So put a number 2 on the front of your foldable and the inside of your foldable about the secondary consumer. It eats the primary consumer. So we're going to look at that arrow. So the arrow from the primary consumer, where is it pointing? Okay, you may say sea slug, and you're right, but we're going to get to that one in a minute. We're looking at the fish. Your fish should be number 2. Hold off on sea slug. And as by now you're probably seeing a pattern for your tertiary or third consumer, go ahead and mark a number 3, and mark that on the inside of your foldable as well. And your tertiary consumer is the pelican. Okay, so I told you to hold off on the sea slug because the sea slug is your detritivore or decomposer. Detritus is a fancy word for dead stuff. Okay, so it's an organism that feeds on dead organisms. And the way you see that in a food chain, if it's represented, is all of the arrows from everything else in the food chain or the food web should point to the decomposer. Okay, because since all of those organisms will die, circle of life, eventually the decomposer is going to eat them all. So your sea slug is your decomposer. Sometimes when you see food webs, like on tests and things, they like to leave out the decomposer and then say, hey, what's missing from this food web? And you sit there and you think to yourself, well, I don't know, it seems pretty good to me, and I'm not sure what all lives in a forest anyway. Usually they're looking for the decomposer or a decomposer in some way. Bacteria are often decomposers or detritivores. So mark your detritivore with the symbol and write example bacteria off to the side. Okay, so getting into some more terms. An herbivore or herbivore, however you want to say it, is an organism that obtains energy by only eating producers or herbs, green stuff. Okay, so circle the herbivore in your food chain. What's the herbivore? The zooplankton. And carnivores, the delicious organisms they are, get to obtain their energy by only eating animals. Put a triangle around your carnivore. So in this case, your carnivore are both fish and pelicans. Okay, also remember you should be making a key on the inside. Okay, and an omnivore, omni meaning all, an omnivore eats both plants and animals. You should draw a bubble around an omnivore in your food chain, except trick, there's not an omnivore in your food chain. So draw a bubble around the word omnivore and write example human off to the right. Okay, food chains are simple. We've done food chains a lot in our life. That was kind of review. Most of the time, how you're going to see stuff, though, is going to be in food webs. And food webs are simply interconnected food chains. So food webs are lots of food chains where we take out the repeating animals and draw other arrows, okay? And analyzing food webs is going to be a big part of what you need to do on your test Friday. Okay, so again, interconnected food chains. They show interdependence within an ecosystem, how all things rely on each other to survive. And the arrows in a food web show how both matter and energy are flowing in the ecosystem. So in the picture on here of the marine Arctic ecosystem, the arrows are pointing where the matter and energy goes. Okay, so the kitty wake, for example, is getting energy in part from the gull, probably through its eggs. This is a really complicated arrow one to decipher. I'm going to show you some easier ones to read here in just a second. Okay, so again, the arrows show where the energy, where the matter goes. I'm going to give you a hint because I do want to see 6 examples on your foldable. Okay, so let's do one kind of together. We have to start with a producer. So in here, we're going to start the number 1, the grass. That's my producer. The energy from the grass then goes to the rabbit, because it eats the grass. And then the energy from the rabbit goes to the mountain lion, because he caught the bunny. That is one food chain within this food web. I want you to find 5 others. So how do matter and energy flow? They flow in one direction. Oh, it's funny and sad because they broke up, if you're into that, I guess. I don't know. I still thought it was clever, so I included it. Enjoy science. Okay, so like I said, energy flows in one direction, and that energy comes originally from the sun. That's the source of 99.99% of all life on Earth. We talked about some chemotrophic examples of like bacteria down in deep sea vents, but basically the sun. Sun's important. Matter, on the other hand, gets recycled in an ecosystem. So remember when we talked about the carbon and nitrogen cycle? Well, the carbon and nitrogen cycle are partially working in food webs. That's kind of what we're showing, because as organisms eat other organisms, they're consuming carbon and nitrogen. So while the carbon and nitrogen cycle are taking a more global view of what's happening, incorporating the atmosphere and the soil, this is a piece of it, okay? Now, when we're examining the energy flow of things, the best way to do that is with an ecological pyramid, because then you can really kind of keep your math straight. Oh, aren't you excited to do math later in the week? I know I am. Okay, and an ecological pyramid is just showing you the amount of energy available to each trophic level in the ecosystem. And I am sorry that I misspelled trophic and just now caught it. Okay, so only about 10%. So when I call this a 10% rule, I'm really saying it's more like a 10% guideline. It could be 9.8, it could be 10.2, but it's about 10%. Only 10% of the energy available is passed on, okay? So if we say a producer has 100% of the energy available, that's where my starting is, then the level of primary consumers only have 10% of the energy that the producer started with, okay? What happened to that 90% of energy? It was used by the producers to stay alive, or it was lost as heat. We can calculate that energy in terms of calories. So if there's 1,000 calories available at one level, 100, 10, 1, all the way down to some decimals. Okay, don't be intimidated by that. I'm going to work with you on the math. Just know that that's your rule of thumb. Okay, and so another way to show you that a lot of that energy is lost as heat or used by the organisms at that level. And at the very end of your foldable, you have some questions over a food web. And I know that the arrows are difficult to see, so I want you to use this picture. It's the same one, but you can see the arrows better. And when you're done with everything, have me come check it. Also, please answer your essential question in the summary section of your journal. And that's all for today.